Hello everyone, this is LeetCode 104, maximum depth of binary tree. Given the root of a binary tree, return its maximum depth. Binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So this problem is a little bit similar to our problem we've done called diameter of binary tree, but it's not exactly the same. Because in that problem, basically each edge counted as a length in the path of the longest path. In this problem, it's not, because it's not like going from 3 to 20 is 1, 20 to 7 is 2. So there's two edges, right? So the longest path is 2. In this problem, you don't care about the edges, you care about the actual node. So the root node counts as one depth, right? So 3 is 1, then you go to 20, 20 is 2, and then you can go to 7 or 15, doesn't matter. And then you go to this 15, for example, that would be 3. So the maximum depth is actually 1, 2, 3. So this root node actually counts as 1 as well. And that's why the maximum depth of a binary tree, in this case, is 3. Now, let's say example 2, which is almost, you basically have a root node. You have nothing on the left, and then on the right you have 1, just have a 2. So that 1 counts as 1, and then you go to this 2, that counts as 2 for the depth. And so in this example, they don't have an illustration, but in this example, if you can visualize it, that's why the output is 2. So yeah, this problem we're also going to go bottom up, okay? Because we need to find the maximum depth, and we need to basically yeah, find the maximum depth, and we're given the root node. So we're just going to go from the bottom up to the root, okay? So the way we're going to check this, okay, first of all, let's make a DFS function, okay? And technically, when I say we're going to the root from bottom up, we are going in the left subtree too. It's not like we're just going from the right subtree up to the root and stopping. We're checking all the nodes. So the way we're going to do this, okay, is we need to have a base case, obviously. So we're going to say if root is equal to null, right? We're going to return 0, okay? Because we're going all the way to the bottom of the tree, so we should return 0 when we hit one of these leaf nodes. When we go down, obviously they're not going to have children, so we need to return 0, okay? So because we need to go bottom up, we need to basically keep going down to the left and down to the right. So we're going to say this, and we're going to say this, okay? Keep going all the way to the bottom of the tree. Now, when we're going up, right, when we hit the bottom of the tree and we're going up, we're basically adding 1, right, because we're going up a level, and we're basically returning the max that we've seen from the left and the right subtree, okay? So for example, at this 15, right, when we're at this 15, we're going to go up and we're going to add 1, okay? Now, when we're here, for example, at this 20, we're going to go up and we'll add 1, so we're going to hit 20. Now, when we're at this 3, right, we're going to return the max that we've seen from the left and the right plus 1. Now, the max that we've seen is 1, 2, right? And so when we're at this 3, the right subtree, the longest path we've seen is 2, but we're also adding 1 to that, so we get 3 as our final result, which is what we expect, okay? So that's how our algorithm is going to work. So we're basically just working bottom up and just counting the paths, essentially. I mean, we actually have to count the nodes, not the paths. But obviously for n nodes, there's n minus 1 paths, or n minus 1 edges. But because we're adding 1 when we take the max of the left and the right, we're technically adding the root node to the count, so to speak. Okay, so yeah, this problem isn't that complicated. I'm not going to over-explain or spend too much time on it, but yeah, there's a few similar problems that we've done already, like I mentioned at the beginning of the video. But anyways, I hope this helped, and I'll see you in the next one.